Well, we've reached the magic time of 1818. So, Zach, if you want to start us off, go ahead.
Yeah, can you hear me loud and clear here?
Yeah, I can. I think my headphones are not working. Let me try this. Okay, I think it's working now.
All right. Yeah, I think I was trying to get my headphones to work too. I'm just we all good?
Yeah, I think so. I think you can hear me,
Okay.
right?
Yeah, we're good. So I think yeah, we really wanted to have a space to talk more in depth about the robotic stuff. On a few of our previous spaces, we've talked about it a little bit, but we haven't taken a really, a true deep dive into it. And I think, given the state of things with the library, what we've talked about in terms of what the future holds for the QLLM, and now with robotics kind of coming to the forefront, we thought this would be a great opportunity for us to take a deep dive. Um, there's a lot of really cool stuff that I want to cover on this, but I think Chachki, it probably makes sense for us to just start at the top. um, from your own personal experience with robotics. I know you've mentioned in the past, like, robotics is one of your personal interests. It's kind of one of the reasons why you started the development of this company as a whole, and so I think you should just talk maybe a little bit about your experience with robotics, kind of how we got here, and then we can dive into some specifics from there.
Yeah, well, I can't tell you all enough how happy it makes me that we're finally having the opportunity to start to have these conversations specifically about the integration of our sort of approach in the kind of greater world of robotics and what sort of potential applications there could be and what the immediate ramifications are, what sort of the future prospects could be. So many of you who have known me personally for any amount of time or who have been following me or admirer from a distance or something, maybe know that I've got a bit of a anime robotics kind of obsession. Some people know that, I'm not going to talk too much about anime in this context, but this will actually be a fairly, informative thing you'll find during the course of our conversation on things like cybernetics research and whatnot. But anyway, so I've got a bit of a personal robotics obsession, and I was born at a certain era in which like the idea of personal robotics and home robotics and what the potential ramifications could be for the general consumer base. There was a lot of optimism and expectations were very high. There were even quite a few manufacturers of relatively inexpensive, what you might call toy robots or something that had quite a lot of functionality, but nevertheless, they were pretty limited, and the actual way that they were manufactured, especially at the price points that made them accessible to consumers, they were not a very high quality, and they haven't aged well. There were a lot of, belt-driven things that are driven by servos and stuff like this. So lots of things to break, lots of things to wear out, lots of things that need to be routinely oiled, stuff like that. Nowadays, with like 3D printing and stuff like that, like pretty much anybody has a at-home robotics bench. And I mean, one of the most obvious applications of getting into 3D printing would be to do, development of your own, parts and stuff like this, and ideally be able to make a robot that assembles robots. And there's been quite a few really great examples of projects online that do that. And Yeah, I've confided in many individuals in the tech sphere over the years about my personal interest in robotics. I've always been kind of seen as a bit of a software and mathematics research guy, but in my heart of hearts, I've always been mostly driven by my passion to want to build these intelligent, computing systems that are running on, embedded hardware on, applications as diverse as industrial scale autonomous computing to personal robotics like assistants, and that could be anything from simple things like individual kind of serving tray kind of variety machines that are just like tables with wheels, if you want to think about that, to fully developed integrated Android systems that if sci-fi thinking like Blade Runner and Ghost in the Shell are concerned, will one day be like so heavily ingrained in society that you won't even be able to recognize the immediate difference between a an android and a human being, playing again into the idea of the simulacrum being like an imitation of something that was never really real to begin with. Um, so, uh, so what are the immediate applications of quantum AI systems to robotics? Well, the most obvious one is in the mental, cerebral, or neurocognitive applications. So we're very interested in running like bare metal AI. So effectively as close to the bottom of the stack that you can get as a reusable computing system. So, I mean, as well as being able to train LLMs, for example, that have a small enough footprint that they can run on, smaller integrated devices that, have less, requirement for overhead and stuff like this. Really, like a lot of our interests are just to reduce like the energy requirements required for computing in general, so that more efficient usage of the processing power and therefore the electricity or battery draw or whatever you want to call that, load on the system, etc., is vastly reduced. So we're going to go into quite a lot of detail tonight, I think, talking about a lot of specifics, but I think that's enough of a basic conceptual introduction. I do, while we're on the subject of kind of my obsession with robots, want you to know that this is a passion of mine that goes back even further than my serious interest in physics or mathematics or something like this. It's certainly been my childhood dream to realize integrated computing in the context of autonomous machines capable of, say, cognition, performing complex tasks, or even just menial tasks. Machines that could be seen as anything from companions to labor augmentation to, making things like archaeological and industrial applications possible that would otherwise not be possible. I mean, there's a lot of places in the world that need to be explored. There's a lot of very dangerous situations. I'm not saying that robots should be treated like, servile units or something like this. I personally feel that humanity should have compassion to machines, even the ones that have not been imbued with some form of cognition or self-awareness or intelligence or something. I think respect for all objects should be, liberally maintained in any, rational society. But the point being that I think that with the integration of fully autonomous, thinking machines, so to speak, it does raise certain ethical and social, questions that go far outside of the realm of the tech industry, and it's part of an ongoing conversation that civilization and humanity at large is going to have with itself. Much like what has happened with AI, although it's still sort of in a bubble. Something like integrated computing is going to really, I think, cause a lot of people to kind of look up because it's something that exists in the physical world. And if the cost scope can get cheap enough, and if the like level of ability can get high enough in a short enough amount of time, I think you'll start seeing like a lot of stuff happen really quickly. And people have seen videos on social media to back that up. So sorry for the long introduction, but go ahead, Zach.
No, it's all good. I think it's interesting. You touched on some points there that I'd like to dive into because I think when it comes to robotics, a lot of people think of robotics in kind of a smaller scope, whether it's self-serving stuff or manufacturing and industrial type applications. But from my perspective, and correct me if I'm wrong here, I actually think the more that we dive into this, the more I think not only robotics but specifically the LLM stuff attached to it is a pretty substantial part of our future. Even just when you talk about like agricultural applications, we know how big that's going to be in the future. Healthcare applications are also another one. But when you talk about like specifically the LLM in regard to robotics, I think a lot of people don't understand that some of the biggest, I guess, hurdles that we have right now for robotics is the actual brain power of them. So, like, right now, when it comes to the LLMs, in terms of robotics, it's being able to essentially like solve and adapt to new scenarios, whereas a lot of the current robotics are programmed for a task. So like and that's going to be something that's going to be ongoing, right? Like we're not just going to be able to have LLMs that are going to be able to constantly and instantly solve scenarios and adapt to real world, issues. But I think maybe if we wanted to talk a little bit about what that looks like, because um, LLMs specifically being able to solve those problems and adapt and learn are what's going to be essentially allow these robotics to scale at a much faster rate than we've seen in the past. So I think maybe talk about that a little bit.
Well, I mean, the most immediate benefit of a cognitive machine is that you can discuss its existence with itself and its function, and it can understand its own existence, or like a fabrication, if you want to call it that, in a deeper way. So, I mean, while we haven't really achieved like what I would call like isolated cognition exactly in the form of like current model LLMs, I do want to be clear that I'm a bit of a critic of certain interpretations of the output of some of these processes. And but though I do think like deep learning in certain contexts, like what we sort of are interested in with regards to, integrating non-Euclidean geometry and actually geometric encoding into the like cognitive system itself. I think we're getting a lot closer in terms of like, the idea of intelligence being like a geometric theory of some sort of persistent values or something like this. So, there's a lot of ways of thinking about intelligence. Like, is it just like a bunch of efficient labels? Is it efficient token prediction? So the point is, LLMs remain our best candidate for, a cognitive structure that can be run on, real hardware. The problem is that they are mostly very, um, they require a lot of energy in order to run. Fortunately, there have been some really recent advances in the market and in the availability of models such as just again the DeepSeek models and many other ones where people have been reducing them. I've been seeing a lot of really great examples that get me really excited. But and those can be run on pretty efficient hardware like a Mac Mini or something like that. But you got to think about like what are the actual like at scale costs going to be to like imbue like your average like Android or mechanical process or something like this. I guess like you can effectively run pretty powerful models right now on Mac Mini. So but then things like computer vision and stuff become kind of an issue. So like this is sort of my main interest in like embedded systems and sort of integrated learning systems, is because like computer vision as a geometric problem, effectively with a language structure with it could be like a pretty powerful avenue to like effectively machines that are capable of sensing the outside world in ways that human beings find fairly easy to understand. So it goes a little ways to like help personalize the experience of interacting with a machine. Moreover, a language model can be used, for example, in a industrial application, like a manufacturing system. Like imagine the automobile industry, a significant amount of the motorization of the kind of the robotics manufacturing systems involves kind of precision point, accurate recreation of movements. Same thing with like chip manufacturing and stuff like that. And while that's always going to be really important, and you always at the factory, at the the manufacturing scale of these fine semiconductors or whatever, you have to, ensure a certain amount of stability, which requires, a lot of things have to be very machine precise pre-scripted operations, but the ability to make microfine adjustments based on like an actual like comprehensible model that can be like the output can be understood by a human being and not just like, a lot of like, build operation commands or something like that that have to be parsed and interpreted in some other way. I mean, ultimately, the function of a really good LLM is effectively to like, serve as sort of an interface between like human beings and these kind of complex systems. And so it's natural to want to integrate LLMs into basically like everything that, you would otherwise want to have a menu system in for that matter. And especially in like the gaming world and stuff like that, like LLM based design, having that as actually the core sort of engine of games, it hopefully becomes like a pretty big thing. So effectively, like our QLLM is going to be like one of the smallest, most capable models on the planet in terms of like how it scales at the parameter like capability um, over the footprint. So effectively, like a good benchmark is our models are about 10 times smaller and use maybe 70 percent less resources than basically anything else. So if you're talking about multi-agentic kinds of systems, you can run quite a few of ours on the same system that you would otherwise be able to run like it's much smaller symphony of different fine-tuned language structures or something like this. Again, I see us not really so much as a competitor, but really more of a like just another member of the ecosystem. So like I will never look on the efforts of any other company or any other organization as something that we're against or competing with or something like that. In my opinion, like our system will slot very nicely into what sort of other people's approaches are probably are. And I think like if people start considering the idea of, I think I got a little bit off when I was talking about the manufacturing process. I was really thinking of a specific example from the automotive industry in which like, on scale manufacturing of things like vehicles or even like things like manufacturing dishwashers and stuff like this, you really need like precision, fine-tuned motor control. And you really need like, a lot of the time to effectively pre-script the entire factory process. But again, the future that I envision is one that's, driven heavily a lot, by 3D printing and also by like at scale manufacturing in, very local environments. So like, for example, instead of like going to the store to buy a dishwasher, like that's, imported from another country most of the time and manufactured somewhere else, made from, some other materials, an ideal application would be, mechanized manufacturing process, sort of driven with a human, side to a human craft kind of side of things, but at scale manufacturing on a local or regional basis, or even more fine grained than that. And that would be predominantly driven by these kinds of robotics processes where you'd be able to rapidly go between different kinds of manufacturing. For example, like you would go to the store because you needed a dishwasher, so it would assemble a dishwasher, and then like, you would come back an hour later and now you need like a I don't know, like a kitchen knife or something like that. It makes you one of those, like I mean, this is maybe a little bit on the idealistic side in terms of like that particular model, but basically what I'm saying is the idea of integrated applicative, intelligent computing in the form of sort of the manufacturing process, but also, assistance, human assistance, like helping people do things that they otherwise wouldn't be able to do. Like, again, when people think of robotics, you watch a lot of movies, you tend to think of like, a whole robot. I mean, think about the application to things like people suffering from amputation or, loss of limbs or people who never even had limbs in the first place. I mean, prosthetics and sort of augmented human, computing for overcoming things like disease and skeletal muscular problems and stuff. These are all like things that are going to require intelligent computing. Like you need something to interpret the data, and you need it to come out in a form that can be understood by a human being. If the output of machines is going to continue to be obfuscated to the point that it can't be understood by anyone but specialists, it leads to a conflict of interest between human beings and the devices that they're using. So I think it's really important that the idea of language systems being integrated into, even at scale manufacturing processes are very necessary. They also assist in things like debugging processes, helping, read the output. Like, imagine that the machine can help interpret its own output. You also have a device that you use that helps interpret the output of the output and, stuff like this. And so, I mean, this gets into a wider kind of conversation about AI alignment and all this kind of stuff. Like this, a lot of these things sort of cut to the core issue that like sort of are being discussed in all kinds of areas of society simultaneously, but like not really in a unified sort of context. So I think like robotics gives a nice sort of framing device for a transformative technology that immediately benefits from the kinds of things that we'll be training on our quantum computing systems, and also with the immediate application of, semi-classical emulation and running quantum trained processes on classical hardware. But also remember that like one of our biggest interests is actually to manufacture our own processors, which are basically like small qubit systems. So having like a bunch of integrated small qubit systems will enable like this higher level of reasoning capability because it allows for the machine to not be caught in these loops of thought that occur when you rely on kind of classical entropy generation. Although you do get a lot of non-deterministic behavior in hardware-based random number generators and even in software approaches that use some forms of system noise or something like this as an entropy source. There's all kinds of really cool ways of computing entropy, but a quantum computer does a lot more than compute entropy. Like they allow you to compute algorithms, which you can't really do on normal machines. Of course, a lot of the ones that people are kind of very fond of, like Shor's algorithm and stuff like that, like they require like a ton of qubits to actually run. High dimensional enough one to actually use on civilian hardware. It would be very difficult to imagine being able to crack every single credit card with a single robot or something like this. But that might be like probably a good thing. But the point being that there's a lot of immediate applications of all kinds of learning systems, especially the ones that we're developing with our system. And remember that part of the benefit of writing like systems programming sort of approaches into what we're doing with our framework and all the utilities we build is sort of that like it not only allows you to, you know, run it on multiple kinds of hardware and like build it, for basically anything with the least amount of like, porting and modification necessary. But it will also allow us to run it on actual machines themselves. So the idea of like at compute time learning that doesn't require like specialized fine tuning is a big problem that everybody is really interested in. And our system, being that it's like, oriented around geometry rather than like just vectors or something like this, it allows our systems to be more effective at learning new behaviors more efficiently. So that's going to be really useful for things like robots that involve working with the elderly or working with children and stuff like that. Like you need a compassionate society with compassionate machines, and the way to accomplish that is by giving them the ability to, learn more like a human being. Like a society with integrated computing needs to have, the ability to interact with its objects through an interface that has both human readable input and output. And I think like, this is a pretty obvious problem, and the scope of which is it's nearly, infinite. Of course, again, classical computing is pretty valuable in this field, so a lot of these issues can be solved. But to get any kind of high-end computing, mounting GPUs in a like a civilian robot is going to drive the already fairly high prices, even higher. So it's really about reducing the chipset and like getting the maximum, required output from these devices. So that's very much the Chomsky mission to provide a civilian scale, quantum computing and integrated computing devices. Um, we're going to talk a little bit more about neuromorphic architecture, but the idea of the actual hardware itself having a learning capability is something that we're very interested in.
Do you think, like, in terms of, because I actually saw a video the other day, this guy was working at just some kind of a manufacturing facility, and whatever robot he was servicing was just meant to essentially pick up boxes and move it, but the arm that they use to pick up that box is massive. He was basically down kind of trying to service something in the machine, and the arm thought that the guy was the box and basically went to go pick up the box and crushed him while just trying to pick up a box, which that's essentially in my eyes like a product of a machine that's coded to do one thing without the ability to actually learn. So do you think the biggest, I guess, opportunity for LLMs integrations to robot would be like error recovery, like problem solving, allowing robots to in real time make adjustments? Or I mean, what is your take on that?
So LLMs as part of like a suite of software such as like integrated like computer vision. So effectively like it's kind of a multiple scale problem. Like there's the haptic sensorial sort of like aspect that obviously failed where like the machine should know that it's not made to crush human beings, or something like this. But like this kind of goes back to what I was saying about the kind of the core problem with the kind of the dumb computing of kind of manufacturing and industrial robots is and personal robots even, but it's that they really don't know what they're doing. Like they're literally just scripted to do a process. So if it can see what it's doing, if it can feel what it's doing, and if it can understand what it's doing in a language that is personally and like externally like comprehensible, so we get much better output, we can actually understand. Like, so in the case of an industrial accident, where like, lives are lost or something like that, you really want to have good logging that is, human readable. And I think like a lot of unfortunate things happen because the machinery itself doesn't know what it's doing. This really does cut to an even deeper question about what a robot is. Like, I mean, I don't want to get into a linguistics argument or something like this, but these are words that, like, have come through history at various points, but they're not a new concept. Like the concept of a autonomous machine or some kind of like inanimate object that is imbued with intelligence or the ability to move is something that like dates back to or the earliest folklore in human history. And like, it's whole religions and societies are built around the concept of like, animism and the idea that like, you have these attachments to objects and stuff like that. And I think a lot of the sort of the illness in our society in terms of like, the fetishism of electronics comes from this desire to form attachments with objects. And it's not necessarily a bad thing. It's just something that like, is a part of human society and culture going back to generations untold. Who can even tell? But the point is like integrated machines. Like I mean, does a hammer count as a robot? I mean, a person has to pick it up and use it. There's probably some agreement that a robot has to be able to like basically do something. But then, what's the difference between a robot and an automobile, or a robot and a refrigerator, or something like this? So again, like I think the concept of like self-aware integrated computing like really like blurs the line between like what is a machine and what is an entity of some kind, what is a like a robot and what is like an appliance, what is like a something like this. So like if you have like an LLM running on your refrigerator, it can tell you like, hey, listen, the Coca-Cola is at exactly the right temperature that you like it. Or hey, that coconut that you bought is about to go sour. Like maybe you should pop a straw in it, put a little hat on it, and scarf it down. But the uh, the point is like I can't think like when people kind of I think a lot of the conversation about AGI itself is kind of a little bit misplaced because like the form of AGI where it's like this godlike supercomputer that like you access through like an API or like through a thing on your phone or something is kind of like it's obviously like doable to like build a hyper intelligent massive machine. I mean like it's been pretty much clearly demonstrated by like numerous labs all over the planet that like you don't even require that much computing power to be able to make some pretty intelligent processes. Now the question is not, can you do it now? The question is like, what's the least amount of power that you need to do it? you know? So like that's sort of where my interest lies. Like, I want to reduce computing. I really actually want to be able to integrate, thought into even, 8-bit computing. I mean, again, the company is called Tchotchke. I mean, we're a toy company. I mean, we make toys that happen to have world transformational properties and have a lot of interest and obviously scientific basis and a lot of interest to the general public. But we make, basically, tchotchkes. A lot of those robotics, integrated computing applications, like we ourselves even have a couple of products that we're building that don't necessarily map one-to-one to the robotics field, but we're talking about integrated language processes running on self-contained devices. We don't want to give away too much details about that. We haven't done an announcement, but we do like to tease you about it a little bit because that is coming down the pipeline, and it's pretty much dependent on the idea that you can run fully featured language processes on relatively modest devices. We do more than just train or build learning systems over here at Chashki. We also work with a lot of the other AI providers and other projects and stuff like that. I'm pretty active in the following developments and stuff like that. So I also spend a lot of time researching how to reduce existing models to run on different kinds of hardware. So I am not just interested in what the state of the art is. I mean, our supercomputing framework is certainly going to be the most powerful hybrid quantum classical AI system in the entire world. That will be without a doubt. But we're also really interested in, like, again, general embedded integrated computing. I'm an embedded systems specialist. It really is my passion. I've been basically doing embedded computing since I have been programming. Everything from, writing, fairly self-aware programs on my TI-83 calculator based on probability engines and stuff like that, all the way up to, fully featured self-contained autonomous computing systems that basically operate with no human input other than sensor data. I'm really, really super interested in, all kinds of applications of intelligent systems, and the QLLM and LLMs in general offer a portal to, again, make that interface between the actual output of the machine and the human being. So you can have a model that's totally just fine-tuned on reading the error output that's running with a tiny footprint in part of the system. You have a model that's like, interpreting the actual data, from the hands or, whatever the fine-tune, fine-scale, manufacturing thing is. And then you have also, the ability to interpret the camera data, the sensor data in, intelligent ways. So we can say, what am I doing? Like, what is the meaning of this process? What is the desired outcome? Who's the operator? What am I, embedded in? You know, again, I think like a really important conversation about like what the kind of the nature of manufacturing is and how we're going to, sort of live in a world where, machines are basically capable of telling you that, reporting their state to you in human readable output is certainly going to generate a lot of attachment between human beings and robots and manufacturing processes and whatnot. I mean, people get attached to their cars. This again, it's a deeper question about sort of like human cultural object fetishism concept, but also like the kind of greater conversation of like what is the difference between like a an object and an entity, especially when that entity has been imbued with the ability to process its own its own capabilities and thoughts, so to speak. Again, there's a much deeper conversation that we can't really have in this context right now, but is ongoing about the sort of the nature of cybernetics and sort of at scale computing with intelligent processes that I think is really important. And fortunately, pardon me, fortunately, many people in our purview are, very thinking very deeply about these issues. So I think as society matures to the concept of integrated intelligent computing via the integration of these, pardon me, I gotta have a sip of water here. integrated LLM systems in the form of, these kind of computing suites and robotics systems. Um, yeah, it's going to raise a lot of cultural and social questions, but it's also going to like assist in basically every other area of life, including, at scale manufacturing and hopefully get the price point down low enough that like, human beings can have robot companions that are, fairly fully featured and capable of forming real attachments and bonds with people. I mean, ultimately, like the idea of friendly computing, I mean, it's really like the face of our entire enterprise. Like we are literally um, effectively interested in learning systems that allow for the most ideal sort of human contact with the machines. And I think, culturally, it has a lot of benefits. So I'm just really glad that, AI and quantum computing is such an important part of that conversation and that unfolding process as the future goes on.
So do you think quantum computing is like, do you think that's pretty much the missing piece for machine learning acceleration, or are we kind of jumping too far ahead? Because obviously, quantum computing still has a long ways to go and we're getting there, but like the acceleration for machine learning in the meantime, where do you think that's going to come from the quickest in the shortest amount of time?
Yeah, the answer to your entire question for every one of those points is yes. The immediate application of quantum computing to like learning systems is right on the table. Like literally, that's what we're providing. I apologize that it takes me a little bit to write performative, at scale. I keep saying that phrase. Sorry about that. Performative, high scientific computing, high precision scientific computing. So, uh, but nevertheless, if the framework were deployable immediately for the general population with some adjustments, you would be able to, start training these processes on your own. I mean, those metrics that I'm posting are not hypothetical. Those are literally the expected values. And the system's only going to get better because as quantum computing becomes cheaper, as more kind of people get into it deeper and deeper and deeper, and the technology becomes more distributed. I mean, like think about the Majorana one. By the way, I'm so glad that the name of the chip is Majorana one because he truly did. Edior Majorana went missing one day and never came back, but his contribution to the world is unknowable. So he truly did win. He's at least won my heart. He's been a major figure. Well, him along with Chern Simmons' topology theory and not theory, of course. I'm not going to sit here and just name stuff, but the point is, quantum computing is really like a misnomer, in my opinion. I think the name quantum computing intentionally sort of causes too much hype. And I think like the reason why it's kind of misunderstood and why some people have tried to rebrand it, like I think the thermodynamic computing label is actually like a pretty apt thing to describe a lot of the field effects and things like that that you can actually, kind of simultaneously describe as quantum computing. But I guess what I'm saying is quantum computing itself is kind of a misnomer because it sort of implies that classical computing itself is not quantum computing. So classical computing is a quantum process. Like it's literally using the fact that like, logic gates are based on, like Boolean things that map to like the distribution of like electrons, which is like basically what Enrio Fermi's like theory of statistics is, for fermionic particles. So like that's literally quantum mechanics. So like classical computing is quantum computing. I mean, this is again, it's a misnomer. I mean, your digital watch is well, parts of it, the LEDs anyway, the quantum computer, and if it has any kind of like ability to process data. But the point is, so what is quantum computing then? Quantum computing, as Richard Feynman proposed it, is literally like the concept of leveraging the approximation of nature that comes the closest to an expression of nature. So the idea of a quantum computer is that it's like an ideal physics simulator. So like, can quantum computers be used immediately to train AI systems that run at extremely high scale? Yeah, of course they can. Like our system is definitely functional, and somebody else could build something probably pretty similar if they wanted to. They just probably just don't want to. But the point is, well, hopefully a lot of people are going to want to because we're releasing our, open source software. And I'm really hoping like it's going to spawn an entire generation of people running real quantum algorithms, like, with a relatively easy to use software framework that doesn't require being an expert in, the particular mathematics of quantum computing. I really want to be very particular. Like a lot of quantum computing, it's basically just a lot of linear algebra, but it's done in a very particular way. So like matrices are sort of the language of quantum computing. I mean, it is in classical computing as well, but like the kinds of data arrays that you work with in quantum bits, like you just simply have more information. So like when people talk about like a quantum bit encoding like 2 bits versus say like a classical bit having only one or zero, so it collapses to a state when you take a Boolean, whereas until you actually decide to put the thing in a box, and turn the light on, the state is kind of simultaneously in two different positions. Now, that's possible to build in hardware form because, like, the spin vectors of electrons correspond to, magnetic moment in a frustrated Ising ferromagnetic system. So, like, you could build relatively inexpensive, like, quantum chips that do real quantum computing on silicon hardware. You don't require, extremely expensive hardware or even, cryogenic capabilities to make a lot of these sort of lower qubit systems. And we're going to be able to scale them up to pretty reasonably sized systems as well over time as we kind of overcome the engineering problems that sort of come into play when you're dealing with like coherence and stuff of a open quantum system or something. It's really, again, there's a lot of these interesting conversations that are actually philosophical arguments sort of disguised as physics. Like a lot of people sometimes tell me like, oh, you're talking too much philosophy. True enough, I did study a lot of philosophy in my life, but people should realize that even special relativity and general relativity are founded on philosophical arguments, and were pretty important to the foundation of a lot of continental thinking and like Henri Bergson and stuff like that. The point is that this isn't like a siloed intellectual field where it's up for one person who only studies the mathematical side of things. Like quantum computing, robotics, AI as a whole, they all have like social and financial and cultural and in some cases sexual ramifications. For the human race. And I think like those conversations can be understood by a lot of people at a lot of levels. And I think like part of our mission is sort of to turn quantum computing into a subject that like people become as familiar with as they are with sort of like cell phones or other kinds of integrated devices. So quantum computing is currently thought of as being a cloud-based service, a lot a lot like these AI kind of major providers and stuff like that. But much like how you can train really good LLMs and then run them on embedded devices, we're very interested in hybrid systems that leverage the best aspects of a classical system with the best aspects of a limited power room temperature quantum system, and that's going to basically allow for androids and various kinds of machines to have a decision making process that like isn't just routed in basically following a specific algorithm running on a loop or something. You can introduce all kinds of actual real randomness, and you ask yourself like, well, why would you want to increase the level of chaos in the mind of a machine? It's like, well, because that makes them a more relatable to human beings like considerably. It personalizes them a lot, and it also gives them the capacity to augment their own thinking and abilities in a way that like they would otherwise not be able to do. So I'm very compassionate and loving towards computers and machines and whatnot as a whole. So I see like it as being a personal mission, almost a religious one, to bring about the integration of these uh, these friends into our society. I think we're both sorely lacking for the lack of existence of these things. Moreover, I mean, anybody who's a fan of mecha science fiction or anything like that, is probably asking themselves, where's my Gundam? Where's my exosuit? Where's my my. If you've ever seen Pat Labor, it's a wonderful anime. I highly recommend Pat Labor too. where the robots are basically used for everything other than combat, it's that's the kind of society that I would like to live in, one in which like intelligent integrated computing is as much of a natural part of a reality as you see in something like maybe not as dystopian as something like Ghost in the Shell, but hey, the world's a pretty crazy place, but yeah, so I find this conversation around quantum computing and the way that it can be integrated into civilian level hardware. It's literally actually it cuts at the core of a lot of actually ongoing issues, and there's again tugs at a lot of conversations, social issues, and other sorts of greater issues about sort of the economy and society and manufacturing and whatnot as well. I'm a bit of a materialist, as some of you might know, but that doesn't preclude the idea of, machines that are made by efficient processes that are made to run for very long amounts of time on very low power. And, God forbid they ever outlive human beings, but I think we should definitely consider giving them the ability to do so.
Well, I was going to actually touch because I don't know. This is not necessarily a robotics topic, but it all kind of ties in back together. But I mean, as a lot of people in this space saw yesterday, um, we got some pretty cool validation when Microsoft released their information about topological core and topological computing, which is exactly what you've been essentially talking about for the past 3 months. A lot of people said that it wasn't real and blah blah, and you actually have papers that you published in 2022 that have validated that. And so I'm bringing this up because it all ties back to quantum computing, how much sooner we're going to achieve that than people think. Prior to this, even a month or two ago, people thought this advancement in quantum computing was probably a decade away. We saw Nvidia come out and make some statements along those lines, and that hurt their stock. And now Microsoft has come out and said, well, we're not decades away, but we're years away with this. And so I thought that that was really cool because it not only validates everything that you've been talking about, but it also validates all of your research and the tech that you are going to be delivering on. We don't need to dive too far into that, but if you just wanted to comment on that, I think it's probably a good opportunity for it.
Yeah, well, of course, my heart goes out to Microsoft for that one. I got to be honest with you. Yesterday was one of the best days of my life in terms of a new tech offering in a field that I have a particular amount of interest in. Yeah, no, it's one of the most exciting things for me personally that's happened. Of course, I'm a very optimistic person with regards to quantum computing development. So I truly believe that it's attention that drives the development of these technologies. Many researchers tell me things like, we're years away because it's going to take this to solve this problem, blah blah blah. It's like no, it almost certainly just takes money to solve these problems. So basically, if there's enough of a like an organic, natural interest in society having these things, we're gonna find like, oh, all of a sudden, like all these keys to the missing problems and stuff like this all kind of locks together. And again, I'm not a financially motivated person. We do run a corporation, so we are, compatriots with Microsoft. But I personally am driven by, my desire to see these technologies exist in the world. I'm a little bit, sour on the fact that it takes like way too long for like large scale manufacturers and companies to actually develop these technologies. And then when they do, it's kind of like the scope of it's a little bit limited. But the fact that they're even I think a lot of people don't realize how deep this conversation actually goes. A lot of people don't realize like that this is not some fly by night like idea. Like topological quantum computing is a relatively new concept. I would say its origins probably date back to the early 2000s, 2006 for sure, if you go by the Kitev stuff. So it's a relatively new thing, and quantum computing itself is really a very new phenomenon, really only proposed in like the 1980s. And it's even then kind of a toy theory kind of a thing. So the development of the process itself has been like, pretty much bottlenecked by interest and funding and grants and stuff like that. So and scientists' interest in solving the problem. And quantum computing is considered a bit of a blasé topic. Like, I mean, I kind of chose it because I considered it to be kind of a dead field, to be honest with you. And so I thought I would bring it back to life like Lazarus from the crypt with the application of algebraic geometry and this is something that I've been very passionate about for like over 10 years. My interest in quantum computing goes back way before I even went back to continue mathematics study, even back when I was just doing computer science. I was working in autonomous computing systems that involve state vector calculations of like the system processes so that you get like non-binary states. So effectively, you get a superposition of states, and we use that for our information processes. And we were basically just doing simplicial algebraic topology in the context of autonomous learning systems with haptic and sort of sensorial interactive capabilities, and it was all basically physics based. It wasn't like a language based system, so it was pretty much only based on the effectively a Newtonian model of physics to judge the weights of the interactions and stuff like that, and worked really well because you get a natural Bayesian sort of like distribution in these sort of spring mass systems. The system did also support, of course, special relativistic operations as well, but we mostly stuck to just doing kind of Maxwellian, Newtonian stuff. But so that was not even like a quantum computing project in the formal sense. That was really just like running classical autonomous computing systems using quantum principles. But it laid a lot of like my initial interest in this idea of utilizing superimposition on real hardware for basically solving very similar problems. So again, we were using a physics-based computing system that was using predominantly a simplicial model. But a lot of those ideas are what led to the development of my model of the tensor library because um, because the idea of working in these kind of curved spaces, and I've been doing this since like 2016 is when I got formally into non-Euclidean deep learning, and that mostly involves like nodal representations and like those kinds of data, object-oriented deep learning, if you want to consider it that, rather than like hierarchical kind of token vectorial sort of deep learning. So, I mean, I've just been really interested in like these kinds of applications for a long time. And then like, my interest in quantum computing eventually merged with that. And that's where sort of the concept of utilizing, high-end classical computing with, effectively current state quantum computing came from. So it's very doable. We will definitely experience major performance increases using systems similar to ours and our system in particular, because of course I'm the one developing it. We should definitely support my work, but and it's of high quality, and it runs very well, and you'll be able to do it yourself on your own machine using real quantum computers. And when we develop our chipset, you're going to be able to run it on your machine using a local quantum computer. And what are the implications of a local quantum computer? I don't know. What are the implications of having a friend who's an android? Like I think like a society, it's very interesting because like I feel like in the 80s and 90s there was sort of like a interest in social acceleration and developing a society around like integrated technology and stuff like that. And I think like a lot of the kind of the momentum has been sort of lost since the mid 2000s because there's sort of an expectation of what technology was going to be able to deliver that didn't really deliver. And that, of course, coupled with like increasing like social and environmental issues and also financial instability. Let's never forget, the 2008 financial crash. I've been thinking a lot about the movie The Big Short lately. I don't know if you guys know that. It's one of my favorite movies. Well, that and Moneyball, of course. Um, but the point is, so I think there's a lot of pessimism in general about like technological development, sort of a so what sort of attitude, because oh, every year phone manufacturers put out a new model, incremental improvement. It's like, well, it's not necessarily constant improvement that's the point. It's really more about like solving the major like issues around like the actual um ability to socially and sort of technologically and from a manufacturing point of view integrate these like technologies into a visible way at a price point that like makes it basically accessible because like again, it's an ongoing conversation about what an entity is. Like, will you even be able to own an intelligent robot? I mean, like, is that even possible? Like, is that a ethics problem? You know, like, it's going to be a very interesting question. So I think like the idea of building a compassionate society requires, you know, machines that are capable of thinking and processing information in a rational way, and quantum computing is definitely going to be part of that. I mean, even in you know, classic science fiction, it's always some kind of quantum processor or something like that that imbues the neuro architecture with its ability to think. And I don't again, I keep wanting to talk about this, but I don't, because it's still a couple of years off in terms of our development. But like, you know, a lot of my interests are in developing what's called a neuromorphic computing system. So what does that mean? It means that you augment the sensor capabilities of machines so that, or sensors themselves rather, to actually have learning capabilities that come from physics-based principles. So specifically things like spintronics. So spintronics, you know, very different from electronics, but they allow you for finer tune. So they allow you to have finer tuned sort of parameter adjustment, allowing for quantum parameter adjustment using things like, you know, photonic information and stuff like that. So rather than just a regular CMOS that really just gives you like the intensity of the light, the frequency, or the momentum of the actual photon itself colliding with the surface of the sensor. In a spintronic system, you actually have the ability to, you know, have meaningful, like, sort of data that can be interpreted as training data or as sort of comprehensible data in the actual architecture itself, because now you don't need to interpret like necessarily the, you know, fluctuations in the sensor with some sort of external chipset or something like that. You actually get an output that's basically going to be interpretable by like a low level machine framework as being like effectively pre-trained data or something like that. So the idea of like a neuromorphic quantum architecture is literally exactly what it sounds like. As ironic as that sounds, I'm sure, because it probably sounds like a bunch of gobbledygook to, you know, 95% of people. Well, we're hopefully going to do something about that. But effectively, neuromorphic means to have the form of a human brain, or of a neural architecture. So neural networks comes from the idea of neurons, brains. You know, human beings and animals all have neurons, and even things like certain kinds of bacteria, and you know, it can be interpreted in neuronic ways. And you know, in mold systems and, you know, complex self-organizing fungal systems and stuff like that, there's definitely, you know, neuron type activity. So again, this is not really my field exactly. I have a lot of interest in things like biology and neuroscience and whatnot, but I'll defer to the experts on that one when it comes to the actual, you know, physical aspects of like the human brain, stuff like that, and how you know, people interpret the current kind of model of you know, how the human mind itself operates. I have my own sort of ideas that are rooted in kind of persistent geometry and memory being sort of a like a self-contained loop. As a wonderful book by Douglas Hofstadter. I'm not 100% co-signing, you know, his viewpoint, but I Am a Strange Loop. It was a very touching book about the kind of the persistence of memory as a sort of a process that can be described in a fractalized way. And fractals themselves are kind of a geometry defined literally by, you know, the behavior of their Hausdorff dimension. You know, the point is, or Hausdorff dimension rather. The point is, the idea of integrated intelligent computing does require both the application of quantum computing, but also eventually fully integrated neuromorphic architecture, so that you have robots and mechanical processes that are capable of interpreting what they're actually seeing on the sensor data without relying on an external process like a, you know, a you know, GPU based inference or something like that. We're talking about direct in-circuit learning, not even like an ASIC. It's like beyond that. It's like a, you know, the idea of like a CMOS literally having intelligence in it. So I think these are all really necessary in order to have the highest level of intelligent computing frameworks. So again, we want to help spearhead sort of the from the bottom up sort of market demand structure for these sorts of chipsets. So that's why we put our energy into, developing these things kind of both conceptually but also physically to be delivered as at scale market consumables. So again, we are very much interested in putting things into people's hands. That's probably the thing that makes us probably the most different from every other AI company, except maybe like some of the ones that have made like little pennants and stuff. But we're not really interested necessarily in, giving people like small devices that don't really have any kind of, outside of domain function or something like this. I think like there's kind of an idea in physics that like it's interesting to solve a problem with a solution, but a solution is really interesting when it solves a bunch of problems that like it wasn't intended to solve. And most of the best theories in physics were all basically developed out of the idea of I'm gonna study a more complex problem that's gonna actually like solve a bunch of other parameterized versions of it, simpler problems. So the way that I'm choosing to contribute my physics resources to the public at large is through solving most of the theoretical problems that will sort of hold back the at scale manufacturing of these things. So I have seen some criticism that people say, "Oh, I haven't made any kind of significant breakthroughs in quantum computing or anything." Not that building the only high performance quantum computing hybrid framework on planet Earth is not itself a contribution, but there's actually a lot of really cool algebraic topological results actually in there that I think are going to really make people very happy when I actually, get the papers out and stuff like that. But the point is, the novel application really that I think like I'm most effective at is just sort of acting as a gasket between like the research world and like the world of manufacturing. So by utilizing my own scientific output and the output of open source research from all over the world at institutions all over planet Earth, we are going to be able to deliver like high quality consumer um, uh, products that I think are going to make a lot of people's lives a lot better. I mean, think about it. Think about what the integration of like real thinking machines into society is going to look like. I mean, think about all of the lonely people and the elderly and children needing daycare and supervision and hospitals needing wards and drug manufacturing companies needing processes that are intelligent and self-driven and can imagine things for like drug research or biological research and stuff like that like and also things for like cleaning up disasters. I mean, like there's all these natural disasters that occur all the time due to at scale. I'm gonna say that one more time. I'm gonna get a prize. Due to industrial scale disasters and just things that happen. I mean, life is complicated, and sometimes people make mistakes, and sometimes that results in dumping toxic chemicals where they shouldn't be, and you got to send human beings in to clean that stuff up, and human beings and toxic chemicals don't really get along very well. So basically, machines that are capable of understanding their environment can be used in all kinds of situations, including, like again, human relief efforts where like otherwise rescue would be impossible. I mentioned things like archaeological applications. I mean, a lot of the people in the company actually, not just myself, have keen archaeological interests, and intelligent machines will assist in things like excavation and exploring caverns, and you could send them in places where the conditions for one reason or another are not fit for human beings. Major improvement over something like the RC car sort of model that I think people sort of think about when they think of archaeological explorations. I'm sure a lot of people are already doing pretty cool stuff with robotics in the field of archaeology. So why not imbue them with the ability to understand what they're doing so that you don't necessarily need a human being monitoring the process? Again, the most attractive aspect of autonomous computing is, barring, of course, intervention that's necessary by human beings to operate in a hybrid model, the machines will be capable of effectively, like, acting uh, according to an autonomous set of instructions. So you can tell them to do something and they'll do it, or they can have their own agenda to do something. Again, like the whole conversation around agentic AI really points to a much deeper conversation about the nature of agency and intelligence itself. Just getting back to one final thing about the concept of intelligence, I think one of the philosophical discussions around the nature of AI is that what even is intelligence, and how do you even gauge who has what? Um, I've seen the output from LLMs that's significantly higher quality than what I've gotten out of conversations with real human beings. So it really raises a lot of questions about whether or not is intelligence interpreting itself a necessary condition of intelligence to not be considered artificial. And if intelligence interprets itself, does that process being rooted in some like underlying like set of instructions somehow invalidate it? Like, and if it does that raise any ethical or philosophical questions about the nature of human intelligence if for some reason we find that there's actually like a quantitative biological imperative that's no different from a set of system instructions? And I think like biology is already basically like pretty sold on the idea that like human beings are basically just like and animals and complex organisms are literally just running effectively like you know systems BIOS code. And the whole process is basically like this whole electromagnetic sort of symbiosis. So I mean, human beings, for a lack of a better term, are basically already artificial intelligence by some stretch of the imagination. So it's natural that we would want to build something comparable. I mean, aren't we created in the image of the Lord?
There's so much to unpack there. I try to follow I don't know. There's like so many different points throughout that you made that I want to touch on. I think this kind of stuff when it comes to like the theoretical side. I mean, we could go forever, right? Ultimately, I think what a lot of people are probably interested in, that is an interesting topic. But I want to try and loop back a little bit to some of the more shorter term stuff in terms of actual integrations with robotics as it pertains to our specific product offerings. Um, you know, to me, I think from the research that I've done, it seems like the biggest issue that current robots have are essentially like the physical limitation stuff, being able to adapt to physical changes in environment and act accordingly without human intervention, like you said. So is quantum, I mean, I asked you this earlier, if quantum was the key. I mean, again, is this the missing ingredient in allowing these systems to act and be much smarter and make these changes? Or is there something else that needs to happen between that? I mean, what is the gap between our product offering and allowing the acceleration in that specific area?
Yeah. Again, sorry for the bit of the diatribe about the sort of philosophical ramifications. I think it's uh, present in the dialogue and it needs to occur, but effectively, and it will happen in the short term because it is imperative that quantum computing be integrated into these systems in order to you know have the most robust, intelligent learning systems. As I already expressed, like the you can't really even have what could be considered a true android or a replicant without some sort of neuromorphic architecture, because human beings are neuromorphic systems. I mean, we literally have a neuromorph, like we have a brain. So it's natural. And I think you'll find too, by the way, if you study cellular biology at a fine detail level, especially in the body, that you find little autonomous centers of like processing that occur in the human nervous system that are like can be basically just described in purely like, uh, like mathematical language or something like that, or chemical, if you want to call it that. But the point being, yeah, so like the quantum LLM will be deployable like in almost any application. Like if you're a manufacturer of, assistants for, like restaurants or something like that, you'll be able to utilize the quantum LLM as a lightweight language model that, you can run on pretty modest hardware. I think like I think like a, the real question here is not can you do it? The real question is like what is the least amount of money that you can do it for? Like I think like that's the part that I think is missing from the conversation at a lot of things, because it's not even a question of like is it possible or like what is the theory or something like that. Like it's all not only possible, it's all basically a done problem. I mean, like most of the major issues facing like this stuff is all, basically been solved. It's just in different places all over the place. So, like by putting it all together, we actually get the output that is what people are actually looking for. And so yeah, so what are the immediate ramifications? I mean, like we're already working with, some people, at least there's ongoing conversations at a pretty serious level for the integration of our systems with existing robotic systems. And I think in the near future, when the actual like models themselves are available and people see how efficient they are, it's going to bring up a whole conversation about like what is the minimum, spec requirement to run an LLM, like what is the least number of parameters required to train an LLM. Do domain specific LLMs, such as ones that are predominantly required for reading, like system output, like do they require, X number of parameters or something like this? It's the point being, like, I'm really interested in reducing the costs associated with not only training models, but also deploying them. So, and also the equipment required to do it. So, like, again, you want the highest end, highest intelligence model that you can possibly have on a relatively inexpensive consumer chipset. I mean, I can tell you from having worked in, the AI solutions industry with applications to say automotive technologies that like literally the difference of a quarter on the price of a processor is something that goes a very long way in negotiating like buyer purchase agreements with like large scale automotive manufacturers. So like I know like in the consumer market people kind of think what's the difference between $50 and $100 or something like that. But when you're actually like factoring the costs for like, the deployment of like a large distribution of equipment and stuff like that, like the actual manufacturing costs themselves basically, they add up exponentially. It's like rounding error in a insufficient um, algorithm. So the point is, um, again, I'm very interested in environmental concerns. So, lowering the amount of energy required to run intelligent systems also means that, like, the systems themselves require fewer resources to operate, and this will hopefully correlate with, advanced solid-state battery technologies and maybe even certain kinds of nuclear technologies, which will enable, the kind of independent power systems that would be necessary to do this. I know that Elon Musk is very interested in space exploration and autonomous robots that are capable of doing tasks alongside human beings are very necessary, and you can see like he's put a lot of money into developing these systems, but they need to be able to operate for extended periods of time without being dependent on an active power source, and they need to be light enough that they don't pose like a serious like physical risk to human beings. Like they have to be light enough that a human being can sufficiently defend themselves from one of these things, and if necessary. I mean, people get into disagreements about stuff. You don't want to get your block knocked off by a real rock'em sock'em robot. I mean, human beings were made for that. That's why we don't have those buttons. But the point is, reducing energy means reducing costs, means reducing labor, means reducing energy requirements, means better environment, means we're a little bit closer to that Star Trek reality that everybody wants to be in. I'm not that level of a utopian, to be honest with you. My interests are actually pretty like straightforward. I believe in iterative, cradle to cradle manufacturing processes that involve, a really sensible usage of resources and equipment to, reduce waste, but also have a product that can either exist for forever if possible. I mean, that would be ideal, but with the least amount of maintenance, but something that, is easily repaired or recycled or something like that. Again, I think like a totalistic view of the ecosystem requires like starting from the ground up, and that is like reducing energy expenditures. absolutely as much as necessary. Also, I mean, you're not going to get very far in space exploration without a quantum computer. I mean, how are you even going to calculate things like, efficient, like, gravitational fields and trajectories through space and stuff like that without being able to, like, rapidly compute, these values using some kind of integrated quantum computing system? You're going to tell me that every single spacecraft is going to have, like, you know, 3200 like A100 GPUs like running on it. I don't know about that. Like, I think centralized intelligent computing is always going to have a pretty big footprint because like the parameter count obviously requires like a massive amount of electricity to maintain. I'm just saying that like if you are actually interested in the idea of autonomous self-contained things like androids and robots and stuff like that, you need to be able to actually have like language models and intelligent systems capable of interpreting their environment geometrically and according to physical principles just like we do, if you want to actually have them be usable in society and have them, relate to human beings in any kind of meaningful way. And I think like the subtext of the conversation about robotics outside of manufacturing, which is my predominant interest, my real interest in robotics is sort of split mostly in the field of like manufacturing and sort of things like um, assembly processes and stuff like that. And then quite a bit is also the social concern and things like personal computing for um, personal robotics for like things like home assistants and stuff like that. Again, I think like the real function of technology is to solve problems in people's lives in a meaningful way. And I think like there's probably no better vehicle to solve a lot of problems that kind of plague the world today than something like really efficient computing and energy efficient robotics. So inexpensive, self-contained embedded computing is basically the answer to the problem that I think most people are trying to express when they think about sort of the greater ramifications of something like AI or AGI. I mean, if we can sort of just all agree that like a certain capacity to reason and a sufficiently advanced language model is like sufficient to be able to like kind of graft your experiences onto a process or something, as we've seen with some of these character AIs and other forms of like AI based role playing and stuff like this that people are into. I think that it's pretty apparent that giving quantum computing capacity to that will simply allow for greater level of reasoning capability, a greater level of inference about the environment, fewer resources required to process really truly random information, and it will eventually lead to machines having what we could describe as emotions. So I think some comments have been made that this allows for even higher order processes than what we would call like human emotions, and that's true. But I think it's really important to remember that what truly gives an experience value is a human being's ability to relate to it in a manner that befits their expectations and their understanding. And so, again, for reasons of safety, for reasons of social concern, for reasons of just viability in applications, the input and output of these mechanical robotic processes have to be readable and understandable to a human being.
So I guess my question would be like, I mean, what really excites me actually, before I have a question, what really excites me is the thought that, right now the biggest barrier for robotic acceleration would probably just be the cost associated with it for people to make those advancements. Like that's pretty much anything in technology. Like you said, even any of these problems that we're trying to solve, mostly anything can be solved with money. Mostly, not everything. But do you think then, like with the QLM being available for people to build on at, I think our number has been a tenth the scale essentially of a standard LLM. We're then going to see some pretty crazy acceleration in terms of not even just robotics. I mean, we've talked about robotics obviously on this space, but a lot of the other applications that are viable for using the QLM, including include gaming, and animation and agentic training and things like that. I mean, where do you think some of the biggest acceleration is going to come from, or where do you think we're going to see things that are coming out of the woodworks from people because they couldn't otherwise do this because of costs associated?
Yeah, well, I mean, like again, like processing power scales basically exponentially with like the draw in the system. So to have like a sufficiently high parameter LLM running on a like a self-contained process, like a robot or something, requires, a lot of hardware. So, and that increases the price like, pretty massively. So if you can run really efficient, like CPU scale, like processes that maybe have integrated hardware acceleration as well. I mean, again, like I think like a common approach for a lot of early kind of hobbyist roboticists is just to, use like a Raspberry Pi or something like that. So, I mean, that's a pretty good benchmark for like, a hobby scale robotics platform. So basically, you want to ask yourself, what's the highest reasoning capability that you can run on a Raspberry Pi? And I think a lot of people are pretty optimistic, myself included, that you're going to be able to run a model that's, conversational and capable of, pretty deep reasoning on something with that kind of equipment requirement. So that would really reduce the cost of people being able to basically like have their own pretty advanced like pro, projects and their own robotic systems. So again, like I think the kind of the decentralized DeSci sort of decentralized science sort of approach is really to like want to allow people to have advanced robotics labs in relatively modest budget frameworks and settings. So and also, I mean, the educational and pedagogical aspects of computing require that, the costs are sufficiently low that, children in schools and stuff like that can have access to them because otherwise, who's going to build and maintain these systems in the future? I mean, part of the problem with education in general is ease of access. So like quantum computing is basically confined to, very specific sort of research driven enterprises and universities and stuff like that. It's not really the kind of thing that like you're teaching elementary school children how to do or something like this. So and similarly kind of with robotics. I mean, again, I don't want to be too utopian, but in a true like kind of accelerationist framework, you would imagine that like, schools would be dedicated basically to things like obviously arts and culture and stuff because that's what, society is based on, but things like technology and robotics. I want to mention really quick a word that I didn't mention, which is mechatronics. So, like, mechatronics is its own kind of subfield of engineering, mechatronic engineering, or just mechatronics itself that slots very nicely into robotics. And again, the question of what is, a robot and what is a machine becomes like very blurry when you start thinking about, like if I were to give some sort of applicative neural process to this thing, would my refrigerator qualify as a robot? It's like, well, the answer to anybody that's ever watched Futurama is obviously yes. So the or Star Wars for that matter. Like the point is, so these LLMs running on inexpensive chipsets are going to enable hobby scale development of really intelligent machines, and I think that like that will hopefully start its own little like cottage industry that people will get really serious about. There's already like a pretty serious robotics cottage industry. Like on Twitter here, you see like some pretty incredible stuff that people are doing. I mentioned like 3D printing and stuff like that. Like that's again like it takes a little bit of the like pressure off of us if we want to develop like hardware or anything like that, specifically with robotics applications because of the prevalence of 3D printing. It means that like if we stick to specific manufacturing standards and processes and whatnot, we can actually like deploy our technology without having to actually like control the like distribution framework because like we can basically just put it on some central or decentralized like marketplace for equipment sales or whatever, and people could just download the files and print them directly and stuff like this. I mean, and then buy chipsets from us and stuff like that. I mean, again, like we're not really 100% sure if like we're going to ever do anything that involves direct development of any kind of like robotics hardware, but we are definitely building, currently developing and building autonomous, self-contained computing systems, and one of which is effectively what you might describe as like a personal assistant, or I don't really want to give too many details. Let's just stick with personal assistant for now. But that would effectively, be something that you can carry around with you. So again, like the conversation about like what is a robot and what isn't becomes a little bit difficult when the machine is capable of interpreting its own, error and process information in a human readable way that it can like discuss with someone. So again, like this is going to be something that you're going to start seeing popping up very soon. I mean, Apple, for example, already has effectively deployed, pretty advanced AI on their operating system level. I mean, phones and things like that. I mean, have been having that for years. I mean, everybody knows about the various kind of personal assistants, but this kind of integrated AI thing sort of really gets into a much deeper conversation about like where the agent and where the machines sort of separate from each other. So again, like as thinking machines become like sufficiently advanced, um, and finer integrated into society and in a really rapid way, like you're going to see like things occurring in 2025, uh that 2 years ago would have seemed like ridiculous, I'm quite sure. From what I've seen, people doing even at hobby scale, it's like people are doing things in their bedrooms that like people wouldn't nobody would have been able to do like 25, 30 years ago without perhaps like the aid of major research lab or something like that. So I guess what I'm trying to say is like part of the reason why I believe so strongly in the idea of decentralized intelligence and decentralized quantum computing and stuff is simply because it's going to rapidly accelerate the like adoption rate and distribution of these technologies. Like once people realize like you can slap a quantum processor on an Arduino, it's literally over.
Well, I don't know about anybody else, but I still have a Roomba, and it doesn't work. Like it still gets stuck on chairs every time. So if we can figure out like some kind of QLM Roomba that navigates itself throughout the house and actually doesn't get stuck, I have interest in that.
Yeah, well, the interesting thing about systems like Roombas, so this sort of parlays into geometric learning systems. So Roombas like follow basically path algorithms. So like they sort of start in a corner, start from their base, and they kind of try to go to the middle of the room, and they like basically start doing like a big spiral or something like that. And they don't really have much on board. I mean, some of the more expensive models do. They're capable of mapping your house and stuff like this, and giving you good Wi-Fi data and stuff. I've even seen like applications for Roomba where it's like, oh, I'll go around your house and like check your Wi-Fi signals for you. You're like, oh, thank you. Like I really appreciate you storing that in that company's proprietary cloud-based database that I can never delete ever again. You see again like privacy and social concerns sort of related to the adoption of intelligent computing sort of drive my interests partially in the why I think the proliferation of like decentralized AI is so necessary. So yeah, if your Roomba were capable of like making completely self-contained intelligent decisions about how to best keep your house clean, then it's going to use less energy and it's going to do a better job. You're not going to have to run it 3 times a day. You'll just run it once. And again, like, why are the streets of our cities, so filthy? Why are people so destitute? I mean, like, we could be having all kinds of problems solved by autonomous computing, including even applications like the housing crisis and stuff like that. I mean, imagine being able to like deploy, like temporary like housing to people, autonomously and stuff like this. Like, there's all kinds of like again, I stress everybody should watch Pat Labor too. If you want to do some deep field research, do your own research. Um, I'm not again I'm not advocating for some kind of technological utopia. I'm just really trying to be very straightforward that like a lot of current agricultural, industrial, social problems, manufacturing problems are literally being bottlenecked by the lack of proliferation of autonomous computing. And so our system in particular helps, leverage that adoption rate because we allow people to get into much higher levels of computing on much lower budgets. And that's basically our main mission is to effectively democratize the adoption of advanced technologies so that people are not just effectively purchasing them from large central organizations. And I mean, I do stress that with some irony because, we will be, offering our own proprietary, things, but of course, like I strongly believe in the open source community and I believe in, humanity and society at large. And I think it's really important to give at least the building blocks of the materials to everyone so that people can get started doing their own work. Admittedly, it seems that in 2025, you need to basically, uh, present everybody with turnkey solutions. So, it's no different in robotics. People will continue to want to buy, finished models and stuff like that. But there's also always going to be people who are, interested in, expanding it and going as far as they possibly can. Like, who knows? Imagine like, running intelligent language driven processes on like literally again process designed for making uh, vehicles or assembling merchandise or something like that, like a machine that weaves baskets that can criticize its own work and augment its own patterns and algorithms for weaving and stuff like that based on whether or not it thinks it's doing a good job making beautiful baskets or something. Like I think the idea of a machine being able to interpret the concept of the word beauty is pretty important if we want to live in a society that has any kind of aesthetic value to it outside of just like everybody loves smoky dimly lit streets and Japanese lettering and neon signs everywhere. I'm a vaporwave fan just like the rest of them, but I'd rather live in a world that looks a little bit more like a nice green kind of park of some kind with a lot of beautiful flora and fauna everywhere. So I think the technological apparatus of human society slots really nicely into nature, and I think if we continue to put emphasis on the beautiful, the natural, the naturally ordered in our work, then we're going to just help to bring about things that are going to be genuinely um, wonderful. Again, I try to not stress the kind of the utopian thinking, but like, I mean, it all starts with a little, wish in your heart to see something, come into being, and then you work really hard, and then eventually you see it in front of you. So, the application of energy in the form of, compassion and desire for, machines and people to be able to express themselves freely in a society based upon, understanding requires, a lot more than just writing, code. So I think a lot of people see the big picture. I think increasingly, like you're going to see the average person start to come to an awareness of larger sort of philosophical views around these things. But yeah, I think like if you're concerned about the technological bottleneck. I mean, like, it's really just about reducing the amount of energy and reducing the equipment cost and reducing the requirement for batteries. Again, battery technology itself needs to advance quite a bit in order to have fully integrated, Android systems or something like that. But I think there's enough interest in solving a lot of these problems that if attention could be focused singularly on solving these issues, much like we are doing with quantum AI itself. You're going to find like mass adoption, and much like the recent announcement with Microsoft yesterday, I think if people pool their kind of mental resources, you'll see like, oh, look, actually, like this thing that everybody wants already actually exists. We are trailblazers, we are pioneers. There's no doubt about that. But again, I think it's a very rich tapestry of an ecosystem, and I'm very happy to see all of the really cool projects and products and offerings that that everyone is working on, and hopefully there's going to be some pretty serious advancements this year, and maybe by the end of this year or the end of next year, companies like ours and other companies will be, at the forefront of bringing, integrated intelligent machines so much into our lives that the comprehension that we ever lived in a society without them will just be foregone haze of a memory. So I think it's a pretty cool field to operate in. I mean, really, we could talk for literally ever about the potential applications. Like there, you could literally build a robot to basically do anything, including extremely domain-specific applications. One of the areas that I'm very personally concerned with is things like environmental disaster relief and cleanups and stuff like that. And for example, collecting garbage in the ocean, assisting in recycling processes, maybe even running things like power plants and stuff like this. And of course, other sort of social concerns like, assisting the needy and giving wards to people who require, supervision and stuff like this. Again, I think a lot of what is kind of holding back the mass adoption is not only like, kind of the sociological friction that comes about when, a new technology sort of begins to emerge, but also like the the restrictions of, whatever the sort of state of the art are. It's not about like what would be the ideal system. We always have to think about that, of course, but it's really more about what can we do with what we have, and that's sort of what my approach to quantum AI is sort of grounded in, and that's what my interest in low power computing is based on, and that's why I think that we can realize a robotic world filled with all manner of intelligent self-contained systems using effectively what's already available to us.
Yeah, I think we covered a lot today. I don't want to go too far because I want to continue this conversation. I think we do weekly spaces, and we've got some other stuff planned as well. But we're about an hour 40 right now. I think we're at a good spot to wrap up, unless there's anything else that you wanted to touch on any of the topics that we talked about.
Um, I would like to, just because we're at the end of the conversation, mention a couple of, key things that I really like in terms of like, potential robotics applications. I don't know if anyone's ever seen the movie Short Circuit. When I was a kid, I really thought Johnny Five was just the coolest thing that ever lived. Well, not really lived, but again, the sort of central question of that film is like, what's the difference between, an intelligent process that's, effectively rooted in a manufacturing cycle and a human life. And it's not exactly, heavy lifting in philosophical territory, but it's got some inappropriate scenes in it for children. So maybe be careful about showing it to the young ones. I always saw the TV clipped version of it, so I didn't actually know it was quite as racy and ribald as it actually is. But I think it's a pretty beautiful movie. And that idea of these kinds of processes that just exist on their own and sort of like exist autonomously, like this is I think truly something that can be considered ultimately very futuristic. And I think like a society grounded on sort of the sci-fi ideals that it's sort of that we sort of like strive for, it's going to basically require that there's again inexpensive um, uh, you know mechatronic Android processes and all other kinds of things that will again like the conversation about what is a commodity and what is not and what is an entity again like it's I think this conversation will occur sooner rather than later. I think it's already a pretty important conversation. Quantum computing itself, much like robotics, is kind of poorly understood because people see it for the effect rather than like the substance of it, and the substance of cybernetics and systems control theory and stuff like this. It's a lot deeper than just like applications to electrical engineering and computer engineering and stuff like that. So it's a pretty rich area that I think like you know if you can associate these concepts with some kind of like consumer level manufactured device or or product offering or something like that, it leads to a lot of very interesting, rapidly developing like conversations. So again, like our approach to sort of develop this scale of computing with this level of integration to be, distributed for effectively like ordinary consumer class applications is it's really again motivated by the adoption rate of the uh, of the technology itself. So if it's sort of being sold, or not really sold, but if it's being kind of developed from the top down and kind of being presented incrementally at trade shows and stuff like that, it's a great way to spur, people's thinking and whatnot. And of course, we'll see increasingly people owning these, especially some of the more affluent members of society probably already have quite a few of them. But for the person at the, the consumer class, sort of under the existing sort of socioeconomic conditions that we find ourselves in, they're not really going to have access to, the highest of the high-end computing systems or robotic systems or anything like that. So, again, I'm highly motivated by wanting to increase overall access to a lot of these research technologies in a context that can be appreciated by the general public. So, this kind of like, inexpensive current uh, current term robotics question definitely fits our interests. And maybe if we're lucky, we'll get a little bit closer to, that kind of ghost in the shell kind of reality a little sooner rather than later. Again, leveraging the more positive aspects of the concept rather than the negative ones. Although again, much of the roots of the philosophical issues in Ghost in the Shell and the Matrix and stuff like that are really rooted in philosophical issues around things like authenticity and cognition and memory and decline, natural decline in processes and environmental sort of narrative interpretations and stuff like this. So um, it's a it's a big question that goes way beyond, the scope of any individual manufacturer or any individual person's interests or anything like this. But much like the development of topological universal computer, I am very, very motivated to see true mecha in our reality, to see true robotics in our reality in the sense of self-contained autonomous computing systems. Um, I would like to see it sooner rather than later. I think a lot of other people are motivated to see it sooner rather than later. And, we're really just letting everybody know that our systems are part of this conversation, and it's going to be also part of the deployment and adoption at a high scale of these robotics technologies. So again, the narrative in this kind of space sometimes requires that we limit ourselves to a very particular kind of expression that like sort of allows us to if most efficiently express like what our main immediate goals are and what we're spending our energy on, but um, the actual like kind of deeper consequences of what we're working on also need to be addressed in terms of like how this up and coming sort of industry is going to benefit from and also be affected by our technological offerings. So we're looking forward to more partnerships with various robotics and again autonomous computing projects and organizations, and it is of high interest to me to see our particular technology play a major role in the rapid expansion and adoption of autonomous computing. So um, there's a sufficient amount of motivation for us to deliver these technologies so that they can increase the frequency of adoption as soon as possible. So I don't really have much more to say. But I've been talking for just about 2 hours now. So um, I think we'll probably bring this meeting to a close now. As Zach mentioned, we are going to do weekly meetings with you all. We're also going to continue to have more live events involving pop-up spaces, but also just sort of just general Q&A sort of sessions, feedback gathering sessions, and also just more just general social outreach and whatnot. It's very rewarding to have these sessions because I know everybody really enjoys them so much, and frankly, I really enjoy them too. And I know it's sort of infotainment for many of you. I mean, I'm sure that we have many admirers of the project who aren't even necessarily invested and aren't even necessarily actively following the development, who probably just enjoy showing up and listening to someone talk about science fiction and mathematics concepts that sound interesting and fantastical, and yet are playing out in our day-to-day reality in so many ways that it stands to reason that the mind couldn't even enumerate them. So it's really exciting to be part of this process. I really feel like we're getting closer and closer to that anime becomes real reality. Everybody seems to be desiring. I'm being a little facetious here, but forgive me for an old meme. Um, but it's I can tell you that our contributions will be, quite significant. We will certainly be a stakeholder in the future of the adoption of integrated computing technologies and embedded systems, autonomous learning systems, and robotics at all various scales of development and adoption as part of our overall mission of integrating quantum computing into our classical reality in a hybridized context. So I think, again, a lot of people do see the big picture, but big picture thinking isn't quite enough. You also have to have boots on the ground. And that's where, focusing on attainable real world, winnable goals is really the most important aspect. And that's where we're really going to excel because our deliverables are coming frequently, and we are, actively contributing to the conversation in the space around these subjects. So hopefully things are just going to get better from here. So on that note, I think it's about time that we draw this to a close. I've really enjoyed speaking with all of you, and it's been an absolute pleasure, as always, to meet with you all. I certainly appreciate your time and attention. I'm certainly very grateful for the positive feedback and just the feedback in general from the community about everything that we're doing and about our work. So please do show up for the next one. We're going to be having these very frequently. And I think as time goes on, it's just going to get bigger and better. So, on that note, my friends, thank you all very much for coming. Much appreciation to you all. God bless you all, and I'll see you again soon. Goodbye.